Hello, welcome back to tomorrow's teaching. Today in our Python course, we are talking about your first computer program, and this will be using the print statement. Go back to your Colab notebook we started last time, or start a new notebook. I have a new one here called Course 3, your first program print. And again, I have mixed the slides with the code so that you can easily see it. If the font is too small for you, you remember Control-Shift plus, Control-Shift minus allows you to change the size of the font. Go to the previous video if you have any trouble with these things, or if you don't understand the environment. In the previous video, I explain it. So now today we're going to talk about the print statement and the easiest kind of program you can create. You make a new code cell and then you type something like this here, print hello world, and this is the classic first computer program that people write. And let us just execute that and see what it will do. I press Control Enter. Now it takes a while again because it's the first time I start this notebook, so it has to connect to the Python instance at Google. This always takes a while. The first time you start it, it takes a few seconds, half a minute sometimes, until it actually runs. But all the subsequent users in this notebook will be a lot faster because now our Python is already started, it's running, it's waiting for us. Okay, print hello world, no surprises there, it says hello world. So how does this work? The print statement, like all other Python statements, has brackets after the statement, and in these brackets you tell it what to work with. It's the same for all statements, right? So print, you tell it what to print. Input, you tell it what to input. Square root, you tell it what to calculate the square root of. So the objects on which this statement is going to work go into these brackets. You can think of it as, the statement being a verb, and these are the nouns on which the verb applies. It's the objects with which this statement has to work. So print, what to print, and then in brackets, hello world. And you see that the hello world is in these double quotes. And so this is one character, the double quote, right? It's not two single quotes, it's two double quotes. So you have to use the double quote character on your keyboard. And this signifies that Python should not look what is written inside these quotes. It should not try to understand it because it cannot understand it. That's the point. Python doesn't understand hello world. It understands print, but not hello world. And so you tell it, just print it and don't look at it further. So the quotes, just tell it, you don't understand it, it's okay, just ignore it, just do what the statement says with this. And so this is called a string, literal. A text, literal. A string means a kind of text, a kind of data that the program is not supposed to understand, but it uses as it is. Lots of string manipulation is necessary in computer programs because we want programs to, speak English, speak German, speak Russian, whatever it is. We want them to print messages that the computer itself does not understand. They are only for you, the user, and therefore you tell the computer, just print that and don't worry about it, what it means. So this is what we are doing here. So it's crucial to understand the role of the quotation marks. As I said, if you try to print the text without them, Python will assume that you're referring to a command or your variable that it should know about, and it will give you an error message, right? So let's try this here. I've prepared this without the quotation marks. And now if I press Control Enter, you will see that something bad will happen in a second. I get an error message. File so-and-so, line 1, print hello world, syntax error, invalid syntax, perhaps you forgot a comma. This also shows you that the error messages sometimes are a little, unreliable. Python doesn't always know what really went wrong. It just detects that this is not correct Python, but it does not always know why. So in this case, it suggests you forgot a comma. This would not have solved the problem. So what the problem is here is that you don't have the quotation marks, and this is a literal string that the program does not understand. So It's sometimes good to have these error messages, especially if you are more used to them and you know how to interpret them correctly. But in the beginning, they can also be confusing. The most important thing is that you know here is an error, and it tells you in this print hello world that it quotes there, it has this little, like a roof, right? This caret. And this points to the age. And so it tells you here is the problem. And this should be already enough to alert you to the fact that something is wrong with the hello. So perhaps I need to quote it. Yeah, so don't always rely on these messages. They are not always very helpful. Sometimes they are, sometimes they are not. It's better to know what you're doing yourself rather than rely to these messages. And now I can, of course, I can repair that. I can enter here those missing quotes and then quotation marks, and then I can execute it again, and then you see now it works, right? So this was the whole problem. Now we can use print also to calculate more demanding things than just, print single numbers or say hello. So calculating within print, here we have it. Let me go there and press the play button, which will execute this. And you see 23 plus 5 is 28. And now, of course, you may ask, okay, what do I do if I want to say literally 23 plus 5 equals 28? I want the whole expression on my screen. Of course, and this is what you see in the next print statement. So what we do here is to say, look down here one line. What we do here is to say print and then in quotation marks 23 plus 5 equals, right? Because this is what we want printed literally. And then we also print 23 plus 5 without the quote so that it is calculated. And we separate the two with a comma. So we can print multiple values, separating them always with a comma. So one print statement can print as many things as you like at the same time, all in one line. And the comma will always insert a space between my different parameters. But you see that I cannot get rid of the space after the equal sign. And I cannot even remove it. It's always there because it's put there by print. Print separates its different arguments with a comma and then in the output with a space where the comma was. Sometimes you don't want it, right? Sometimes you want to change it. You want it to look different. And this is why we use print different separators for the print statement. So by default, Python places a single space between each item you ask it to print. In this example, we just had this results in this unwanted space. You can control this behavior using the sep parameter, the sep argument to print. So you just add another argument, which now is the separator. And this goes, you see here at the end of the print expression, I just say print this and that, and then comma, this should be your separator. And by setting the separator to anything you want, you replace this space by whatever you say. So in this case, we put it to an empty string, which makes the output look cleaner because we don't have the space. Let me execute it. And you see now the separator has disappeared. I still have these spaces here, right? Because these I entered myself, they are quoted. Python is not going to touch the contents of a quoted string, right? If it's quoted, it's quoted. It stays like it is. But of course, now these I can remove by hand, Control Enter, and now I'm rid of all the spaces in my output. Here we go. And you can set the separator to whatever you like, right? So here I set it to XXXX, and let me execute this. You see that this also works, right? You can set the separator to whatever you want. You can print anything. This is useful because often we want to print, for example, tables which are separated by a specific character. Sometimes you want to have a colon or you want to have a semicolon. If you want to process your data later with Excel, let's say, or with another spreadsheet, or you want to have a comma separated list, so then you want to insert a comma. So whatever you want, you just put it into the separator and then it is executed. So one last word, because at the beginning of this page, you see it now, you saw this cryptical output streams. I just want to mention it. Sometimes when you read books about Python, you will see output streams mentioned. A stream is like a river. And the idea here is that when we are outputting things with print, we don't know exactly where they will end up, right? So if this was now running on your computer, the output would go directly onto your screen. Or if you run it in a little terminal text window, it will go into this terminal window. Or if I run the same program now in Google Colab, it ends up in this output area of Google Colab. And I could also just redirect this into a file. Then print would be writing into a file. So it's not clear where the output will end up. It's just output. And so Python and other programs have this concept of an output stream, where the user, the programmer, just prints to this standard output stream. And what this really is, where it ends up specifically in the hardware of the user, depends on his computing environment, right? So I could use exactly the same program, but redirect my output stream, redirect it to a file. And then I would have all these outputs in a file. Or I could redirect the output to another screen, let's say, or to the internet. And then it sends it somewhere to another server. I can still use the print statement. I just need to redirect the output stream of my program. And so this is the whole concept of output streams. At the moment, we don't need to worry about it. We always print to the standard output stream. I just want to mention it because you will see later at some points we will meet stream standard output. So just that you know, standard output is wherever the program outputs things by default. In this case, it's the Google Colab area. The same program would work also without Google Colab. Then it would output on your personal screen, wherever you started it on your computer. Okay, that's it now. Thank you, and see you next time, where we learn about variables, another very exciting topic. See you then. Bye-bye.